What is a computer, and how does it turn electricity into apps, games, and websites? Welcome back to Loop. I'm your host Mike, and this is episode 1 of Let's Learn Java. Today, we're answering the fundamental question, what is a computer? Let's dive in. A computer is an electronic device that stores and processes data using a combination of hardware and software. Hardware is the physical infrastructure, and software is the invisible set of instructions that controls it. A computer system consists of 6 major parts: the CPU, memory, storage devices, input and output devices, communication devices, and a physical data highway built into the motherboard called the bus. Information is stored as a massive grid of microscopic switches, each represented by a bit, 0 or 1. The minimum storage unit is a byte, which consists of 8 bits. A small number like 3 can fit into a single byte. Larger numbers or complex characters require multiple bytes. Computers use encoding schemes like ASCII to translate characters into specific byte sequences. When we talk about memory, think of RAM as an ordered sequential line of billions of bytes. Every single byte has a unique address, like a house number on a long street. Because the CPU can jump to any memory address in any order instantly, we call it random access memory. So when you buy a computer with 16 or 32 gigabytes of RAM, you're looking at roughly 16 to 32 billion addressable storage bytes available for your active programs to play with. Hardware by itself is just an expensive paperweight. It needs an operating system, like Windows, macOS, or Linux, to manage it. The operating system acts as the middleman between the user, application software, and physical hardware. Its main jobs are 1. Controlling and monitoring system activities, like handling keyboard inputs, screen outputs, and file security. 2. Allocating system resources, deciding how much memory and CPU time each program gets. And 3. Scheduling operations to keep everything running smoothly to maximize performance. Modern operating systems use 3 major strategies: multi-programming, letting multiple programs like a web browser, Spotify, and a word processor share the CPU simultaneously by jumping between them during idle millisecond gaps. Multi-threading, allowing a single program to execute multiple tasks at the exact same time, like editing a document while it auto-saves in the background. And multiprocessing, running multiple programs concurrently across multiple physical CPU cores. But here's the thing. All of these programs, every app, every game, every website, they all start as code, and that code is written in programming languages. Computers only understand one language, native machine language, which is pure binary code. Writing in binary is nearly impossible for humans, so developers created assembly language and eventually high-level languages like C, C++, Python, and Java. Java was created by James Gosling and his team at Sun Microsystems back in 1991, originally called Oak for consumer electronics, and was redesigned in 1995 for the web. What makes Java special is its core design philosophy: platform independence. When you write code in C++, it compiles directly into machine code for one specific type of computer. If you want it to run on a Mac and a Windows PC, you have to recompile it separately for both. Java fixes this with an ingenious 2-step process. First, you write your source code, then the Java compiler compiles it into bytecode. This bytecode isn't machine code yet. It's architecture neutral. To run it, you use the Java Virtual Machine, or JVM. Every operating system has its own JVM implementation. The JVM reads your neutral bytecode and translates it live into native machine language for whatever computer it's running on. Because of this, Java earned its famous mantra: write once, run anywhere. Plus, Java comes packed with the Java API, a massive built-in library of pre-written tools so you never have to reinvent the wheel. Now, Let's look at the structure of an actual Java program. Every Java application is built out of classes and methods. Here is the classic introductory code. Let's dissect every single element here so you understand why it's written this way. First, public class welcome. Every Java program must have at least one class. The file name must match the public class name exactly. So this file must be saved as welcome.java. By convention, class names always start with a capital letter. Second, public static void main. String array args. This is the main method. A class can contain multiple methods, but the JVM specifically looks for main as the entry point where execution begins. Third, system.out.println. Inside parentheses, we put the text we want to print. Welcome to the loop, with quotation marks around it. This is a statement that prints text out to the console. The words, welcome to the loop, form a string, and strings must always be enclosed in double quotation marks. Fourth, notice the semicolon at the end. That is the statement terminator. Leave it off, and the compiler will instantly throw a fit. Finally, any line starting with 2 forward slashes is a comment. It is completely ignored by the compiler and is only there for human developers to document their code. Keep in mind, Java is case-sensitive. If you write main with a capital M instead of lowercase or system in all caps, your code will break. Java cares deeply about capitalization. When you start writing code, you're inevitably going to run into errors. Remember, there are 3 main types. 1. Syntax errors. Typos, missing semicolons, or unclosed quotes. The compiler catches these right away. 2. Runtime errors. Errors like division by 0 that cause your program to crash while it's running. And 3. Logic errors. The code runs fine, but your math or logic is wrong, leading to incorrect results. That's it for episode 1. What did you think? Was this helpful? Let me know in the comments. If you enjoyed this, subscribe and hit the bell so you don't miss the next episode. Thanks for watching, keep on looping, and I'll see you next time.